let's take a look at identifying a geometric sequence. We're going to find the first four terms of the sequence. Doesn't say it's geometric. We're going to determine whether the sequence is geometric. Well, based on the last video you watched, I hope you just watched the previous one, 8.3b, but you know that a geometric sequence has to have a common ratio. So we're basically going to be looking, hey, does this have a common ratio? In order to find out, we're going to get some of the terms of the sequence. So this, you might be looking at this going, why in the world is that b sub n? Well, b sub n is the same as a sub n. You can use different variables for the particular term. So, you know, they're just mixing it up a little. So b sub 1, let's find that first one. First term, negative 4, 2 times 1, which is negative 4 to the second, which is 16. Okay? So let's find b sub 2. Negative 4, 2 times 2, so that's going to be a negative 4 to the fourth power, and that ends up giving me 256. b sub 3 is negative 4 to the 2 times 3 power, which is negative 4 to the sixth, which is a big old 4,096. And it did say to find the first four, so we'll go ahead and find one more. We can tell right now by looking at it if it has a geometric, a common ratio. But we're going to go ahead and do what the directions say. So that's 65536, 65,536. So let's take a look. We have 16 to 256 to 4,096. So what's the thing that's happening between here and here each time? Well, it looks like that my R is 16. So we're multiplying by 16. And so we're going to say yes, this is a common ratio. This is a geometric sequence. And I'm going to state the reason because the R is 16. We did find a common ratio. There's the proof. Okay, let's go ahead to the next example. So on this one, now this is a recursive formula. Recursive means that we have to have the previous one before we can get the current one. So you notice what they have to give us. They have to give us the starting point. And then they tell us that we can't start with the actual first number in the natural number set. We start with 2. Well, that's because they've already given us the first one. And if we put in a 1 into the end position right there, then we'd have a sub-0, and we don't have a sub-0. We don't have a sub-0 position. So let's go ahead and take a look. For a sub 2, because we have a sub 1, plus it says to start with 2, we're going to write negative 3, and that's times a, and then watch. This is a subscript. It's going to be a 2. Notice I'm putting a 2 everywhere I see an n, right there. There's an n, there's an n. I'm putting a 2 here and a 2 here. Now, it takes a little bit of repetition to really get what is going on here. So I'm going to let you be patient. So negative 3. Now what this is asking for a sub 1. It's saying go get a sub 1 and put it in that spot. Okay? This a sub 1 is 1.05. So we find that a sub 2 is simply a sub 1 times negative 3. And a sub 1 times negative 3 ends up giving me negative 3.15. So that's a sub 2. Now, I'm going to change up colors a little bit to hopefully help out. Now we're at a sub 3. So a sub 3 is found by taking the negative 3, a 3 minus 1. So a sub 3 is negative 3, a sub 2. Well, that means go find a sub 2 and plug it in there. Well, we found a sub 2 to be negative 3.15. Then a sub 3 is, looking at my notes here, a sub 3 is 9.45 positive. Okay, I'm going to move over here a little bit more. Okay, we're going to find the next one, a sub 4. Now, you could do the rest of you could do a whole list of these with just realizing that every time we're multiplying the previous one times a negative 3 to get the current one. Excuse me, we're multiplying the current one, previous one, pardon me, times negative 3 to get the current. So, I'm just going to go ahead and keep using the formula, though. A sub 4 minus 1. So, a sub 4 is equal to negative 3, a sub 3. A sub 4 is negative 3 times the previous one, which was 9.45. And that's going to give me negative 28.35. And I can't even remember what the directions said. Oh, list the first four. Well, they've given us the first one, but we didn't have to list that one. So a sub 1 is given. There's a sub 2, a sub 3, and a sub 4. So what is happening between 105 and 3.15? So what we see is that it's multiplying by negative 3, right? Times negative 3. And this one to this one, of course it's times negative 3. So we can see very clearly that we are going to say yes, and that's because the common ratio is negative 3. All right, so that is a geometric sequence. Even though it's recursive, it's geometric. Okay? So, let's take a look at this next one. We're going to start, oops, excuse me. This one does not tell us to start with 2 because it's not recursive. So we're going to start with 1. 5 times 1 is 5. A sub 2, 5 times 2, 10. And the next one's going to be what? 15. The next one's going to be 20. Well, what's happening between here and here? It looks maybe like it's multiplying by 2 times 2 question mark, but then we look at this next one, and that doesn't work because that's not happening between 10 and 15. So what's happening here, though, look, is we're really just adding 5. Well, because we're adding 5, this is a common difference, not a common ratio. That's a common difference, the difference between the numbers. So we're going to say, no, this is not. It has a common difference. Okay? So I hope that's clear on how to tell if a sequence is a geometric sequence or not. And thanks for watching.